Alright, so we're in Houdini and you can see that I already have a simple scene set up. I also changed the global animation setting so that I have real-time playback and play every frame so that everything works correctly. And let me go through the geometries that I created here. So first of all, we have cloth geometry. So this is the yellow thing. And if I go inside, you can see that the first thing I created is the planar patch. The only thing I changed here is the build plane from YZ to ZX, and I also resized it. Then I applied transformation to it using transform node, then color, and finally null, renamed it to outcloth so that I know which one it is. Let me go back to the object level. Then I have two spheres. One of them is going to be a deforming object, and one of them, the blue one, is going to be an RBD object. So if I go inside the deforming object, you can see that I have the sphere, then I moved it, then I have the color, and then I have the null, so quite similar to the grid setup. However, in the transform node, I have some keyframes. So if I play it, you can see that at frame 25, it starts moving, okay, and moves to the right, from the left to the right, so we can see from positive x-axis to the negative x-axis. So this will be a deforming object, it's animated. Then we have also a static object, which is the tube, and crack test geometry, so this animated character. And in here I have crack, I have the unpack node, then transform, and a time shift because the animation started too late, so I shifted it by 150 frames, and then I have the out null. Okay, and let me show you the tube. So again, the tube, polygon primitive type, then I switched on end caps, adjusted height and radius, and then I have the transform node to move it up, color again, and the null. Brilliant. So we want to start adding these things to our simulation. So first of all, let's have a look at the collisions tab. In here we have static object, deforming object, surface object, and the ground plane that we're going to use. So a static object will be our tube. So it's an object in your scene that is not moving. It will be colliding with other things in this scene, so for example this vellum cloth or RBD object. However, it will not be affected by gravity or other forces. The deforming object, however, is an animated object in our scene, so it can be either this green ball because I keyframed it, or crack test geometry because it's animated. So deforming object refers to animated objects inside subgeometry, and you can see that the sphere is animated inside the sub network. So inside, so I use the transform to animate it. Then we have a surface collider, and the difference between static object, deforming object, and surface collider is that these two, and you will see it a bit later, use volumes and surfaces, whereas surface collider only calculates surface. So it's a bit faster, and it's also a preferred collider for Vellum, and you can even see it here. If you go to the Vellum tab, you can see we have all our Vellum tools, the main Vellum tools, and also the surface collider. So this is what we'll use for Vellum. In RBD shelf, we also have one more tool we're going to use today, which is called RBD Hero Object. And RBDs are objects that interact with other objects in the scene and also are affected by forces in the scene, such as gravity. The tools we can see here are quite similar. They are just presets that we can use. So it's the same RBD object, just with different settings. Okay, so let's start by turning this grid to Vellum. So let's go to the Vellum tab, select our cloth geometry, click on Vellum cloth, and after a second you will see it takes us to Autodop network. Let's go back. I will just move it all here. Okay, and when I play the simulation, you will see that the cloth is falling down. It's affected by gravity. However, it doesn't interact with anything else in the scene. So to make it interact, we need to select our tube, our static object, then go to the collisions and apply static object to it. So make sure to select it, then click on static object. And now let's double check if it's done it correctly. So let's go inside Autodop Network, L&H. And here we go. So that's our tube. That's the static object. And when we play the scene, it now should interact nicely. Brilliant. So we can see several things here. First of all, the cloth is interacting with the static object. The tube is not moving, it's not falling down, which means it's a static object. And also the cloth is interacting with itself. So let's start with that. I will select Vellum Solver and see what settings we have here. So from the top in the Common tab, we have Enable Collisions. If I switch it off and rerun the simulation, you will see that I switched off all collisions. So again, the cloth is not interacting with anything. So let me switch this on. Now if I switch off self collisions and play it, you will see that the cloth interacts with the tube. However, it doesn't interact with itself. So it doesn't bounce off its own surface. So again, we want to switch on self-collision. Then when you scroll down, you will see two more groups that we're interested in for collisions. So first of all, sub-steps and constraint iterations, we'll discuss them a bit later. And then collision passes, post-collision passes, polish passes, and layer shock. By increasing the number of collision passes, you will increase the collision detection quality. However, it will also take more time to simulate the scene. So sometimes it's better to leave it as it is, so by default 10, and then increase sub-steps. It's sometimes a more time-efficient solution. Then we have post-collision passes. This is the next step, the final step of collision detection. And collision passes, post-collision passes are responsible for detangling the cloth, so fixing intersecting layers. The next thing we have here is polish passes. If you have a lot of layers and you can see that some layers are too close to each other, you want to separate them, you have some intersecting layers. This is another way, an efficient way of separating cloth pieces. So a higher value will result in more effort put into separating the cloth layers. And finally, we have layer shock. And this one is very useful for controlling how many instantaneous collisions you expect to have in the scene. In other words, it controls how many layers force is transferred through. So if we have 4 layers, we would use a value of 4, which means if we stack them on top of each other, a layer at the bottom will be affected by the force from the layer at the top. So the force will be transferred through all the 4 layers. The layer shock value doesn't have much impact on the performance, so it's better to have higher value than lower because it's very important. Okay, now let's have a look at the tube. So if I select the tube static object and scroll down, go to the collisions tab, we can see volume options in here. Let me switch on collision guide, and then I will just hide other objects and also hide display geometry, switch off display geometry. Now you can see a representation of our tube. So this is what Houdini sees when it tries to calculate the interaction between the cloth and the tube. And if I scroll down even more, I can adjust the division size. So the lower the division size, the more detail we will have on the collision geometry, but it will also take more time to simulate. So you need to adjust it to the scene that you're currently working on. In the second tab, however, we can adjust the surface. And if I increase the collision radius, let me just show collision radius, you can see that I can offset surface of this geometry, and sometimes that might be helpful for cloths. Okay, let me switch that off and also switch off collision guide and switch on display geometry. Okay, let's go back to the object level and use the second tool from here, so the forming object.